Hi, students. So I want to talk about understanding what's going on with our magnet coil investigation. This is like our building understanding. So where I want to start is I want to go ahead and present this slide here and just talk a little bit about this phenomenon. Okay, so let me go ahead and make me a little smaller here. I'll put me in the corner. All right. So what I want to talk about is this slide right here. So just reviewing some things about forces and energy. So right now, we need to remember that when something moves, we say that it has kinetic energy. All right. So when something moves, we say it has kinetic energy. So when this pen moves, right, that process of falling, it has what we call kinetic energy. All right. And that energy has to come from somewhere. All right. It comes from somewhere. We may not know where, but it comes from somewhere. But when it moves, we say that it's transferred. So we're transferring energy. So just to recap, when something moves, we say it has kinetic energy. The energy has to come from somewhere. And then when the energy moves, we say that it's transferred to another object. Okay. So we just want to think about, do magnetic forces always transfer energy? And then what evidence would we look for to determine if energy has been transferred to or from an object? Right? So answer those really quick. And what we want to go back and think about now is, so sorry, one second. So let's think about those questions. So when we go through here and think about these questions, right? So do magnetic forces always transfer energy? All right. The answer is yes, right? Those are always going to transfer energy. And when we're looking for something, um, and to determine if it's been transferred or not, what we can look for is there movement? Because if we know there's movement, we know there's kinetic energy. So do magnetic forces always transfer energy? Yes, they do. And then what evidence would we look for? We would look for that movement or that motion. All right. We would look for movement or motion from that. Okay. All right. So we're going to go ahead and go to the next slide here. So really quick, when we're representing forces, we're going to do it in a way like this. Okay, so make sure whenever we're doing drawing or representing forces, we're having an arrow, all right, and we're using colors that can represent where that force is coming from. So we show forces by drawing arrows, and usually the size of the arrow pertains to the amount or the strength of the force. So small arrow, little force, big arrow, big force. And in this diagram, we can see that we've got a blue arrow and a red arrow. Okay, so the blue arrow is showing that it's coming from the magnet on the coil. And the red arrow is saying that's coming from the coil on the magnet. So in this instance, we're seeing that these two things are exerting a force that is pushing them away from each other. Remember, we call that a repulsive force. Okay, so the coil is pushing the magnet this way, the magnet's pushing the coil this way, therefore they move apart, meaning they're being repelled by each other. Okay, so we represent forces, make sure we're using arrows and colors to do that. Now, I want to go ahead and talk about these short few questions here. So I'm going to try to put me up at the top, and maybe I can make me a little, we're going to cut off the notebook there a little bit more. Um, but I want us to go back to that prediction we made in our notebook. All right, so look back at your prediction. Just think really quick. How did those results compare to how did our results in this lab compare to our prediction? Were you right or were we wrong? Okay. Moving on though, I want us to think about, is there a force of the magnet? Is there a force on the magnet from the coil? Okay, so is there a force on the magnet from the coil, and how do we know? Okay, so let's think about that. Okay, so there are forces between the magnet and the coil, right? There are forces between the magnet and the coil. Now, there's not forces all the time. Okay, for instance, the only time there is not a force between the magnet and the coil is when it's not plugged in, right? Just like this right now, if I hold the coil up to a magnet, nothing happens. It's got to be plugged in, so it's got to have that electricity flowing through it for there to be a force. Okay, and we know that there's force between the two because we're seeing movement and motion. Remember, that's kinetic energy. So there has to be some sort of energy and force being exerted because we're seeing movement. It's got to come from a force, right? A push or a pull. Okay, so let's move on to the next one now. Number three says, is there a force on the coil from the magnet, and how do we know? Well, is there a force on the coil from the magnet? The answer is yes, because if we flip things, right, we're seeing both pushes and pulls. So when we had our magnet and coil together, we know that the coil is exerting force on the magnet because they are pulling in on each other. All right. And if we flip the coil, all of a sudden, then they're pushing away. So they're exerting forces on each other. And we know that because we're seeing both those attractions and repulsions. Okay. What can we do to switch the direction of the force between the magnet and the coil? Okay, well, there's two things we can do, right? We can take these and we can flip the magnet, or we can take our coil and flip that. So notice by flipping the orientation, just meaning the direction that they're pointing, we can change the direction of the force. And then lastly, did the kinetic energy of the magnet or the coil of wire change, and how do we know? Well, we know the kinetic energy changed because they moved, all right? So by seeing that movement between the coil, so seeing the movement on the coil being either pulled in or pushed away, we know that we're seeing that kinetic energy there because we're seeing that movement, okay? All right. So just to reiterate, um, that is what we've been covering there. And I want to make sure we have that shared understanding of these things, okay? Because these are important things, right? This is an increase, or this is an addition of what we're learning about our coils of wire and our magnet, okay? So just to reiterate, there are forces between the magnet and the coil, and that's only when the coil is connected to the battery. Just like in a system with two magnets, we can get both pushes and pulls between the magnet and the connected coil. And just like in a system with two magnets, we can get the connected coil of wire and the magnet to switch the type of force they're producing if we flip the orientation. And when the connected coil of wire or the magnet move, they have kinetic energy, and we see that in their movement. All right. So moving on here, you now need to track our learning. So in your science notebook, you need to find your progress tracker, and you're going to record some more information. So in your progress tracker, you need to record what our lesson number and our question is. Remember, for lesson 2, it is what can a magnet pull or push without touching? Lesson 2. And then you need to write down what you figured out. So this can, remember, be any combination of pictures or words or whatever you can, but we're going to keep track of our ideas, okay? So remember that it can be any combination of pictures or words to record your ideas, but I want to make sure you record what we figured out. And that should pertain to what we just discussed in these discussion questions, right? All right, so that is our learning for the day. All right, so make sure you go ahead and do that exit ticket. Otherwise, make sure you record what you have in your progress tracker, and I will see you next time on Monday. All right, bye guys.